For more than 50 years, the RMI at UCL has been launching Ozonesondes 3 times a week with big weather balloons. This short video follows the life cycle of such an Ozonesonde. Approximately 1 week before the launch, the Ozonesonde, consisting of a pump and electrochemical cells, is tested for the first time. Although it has already been tested extensively by the manufacturer, some additional checks, conditioning and sometimes even a cleaning are required. At the day of the launch, additional fine-tuning checks and calibrations are performed. First, the cells are filled with fresh chemical solutions which only react with the ozone molecules in the atmosphere. The measurements from this Ozonesonde are then compared to ozone values generated by a reference instrument. All measured values are noted down carefully. An Ozonesonde which deviates too much from the reference value will not be launched. Next, the flow rate of the pump is measured. More specifically, the time needed to pump 100 milliliters of air is measured. The Ozonesonde is approved for launch only if all measured parameters fall within the range of previously determined thresholds. In the shelter, the weather balloon is filled with hydrogen until it can carry 2.4 kilograms. With decreasing pressure high in the atmosphere, the balloon will expand up to a diameter of about 10 meters. At this point, usually around 35 kilometers altitude, the balloon will explode and the equipment will fall back to Earth. A parachute is attached to the balloon to prevent a hard landing and eventual damage to both the equipment and the landing area. A radiosonde, which is essentially a mini weather station, is put in the ground test unit where it is initialized. Using the interface provided by the manufacturer, a connection is made between the radiosonde and the computer. The radiosonde is connected to an Ozonesonde and is attached to the styrofoam isolation box containing this Ozonesonde. The radiosonde will now transfer real-time observations of ozone concentrations, temperature, relative humidity, air pressure, and its position. The latter allows to determine the wind speed and direction and also the air pressure. The position is determined with the help of a GPS, which is also tested for a final time. The ultimate test will check the response of the Ozonesonde to ozone generated by a UV lamp.
Ozone soundings are important as the impact of ozone depends on the altitude at which it resides in the atmosphere. High up, above 15 kilometers, it protects us from harmful solar UV radiation. The use of CFCs depleted this layer and eventually caused the appearance of the Antarctic ozone hole. Around 10 kilometers, ozone acts as a greenhouse gas, and near the ground, ozone formed by photochemical reactions between pollutants can cause health problems. To have better insight in all these effects, it's important to know the variations in time and space of ozone concentrations. While satellites give a global perspective, only ozone soundings deliver high resolution information on the vertical distribution.
The launches take place at Uccle 3 times a week, on Monday, Wednesday and Friday at 11:30 Universal Time. This has been done since 1969, so for half a century already. As already mentioned before, the balloon reaches an altitude of about 30 to 35 kilometers. This ascent follows an average speed of about 5.5 meters per second and lasts for about 1.5 hours. At Uccle, the vertical distribution of the temperature, shown in red, and the ozone concentrations, shown in purple, are followed in real time together with the trajectory of the balloon. The data are transmitted through radio waves, which can also be picked up and decoded by radio amateurs. Some of them have made a hobby out of chasing ozone sondes, and one of them has even sent back more than 200 sondes. When the balloon explodes, the sonde falls down to the Earth and it can reach a speed of about 200 kilometers an hour before it is slowed down by the parachute. As the air becomes less dense, the speed drops to about 5 meters per second. On average, the descent takes about 45 minutes. Depending on the wind direction and speed, the balloon can travel large distances in any direction. Still, the radio amateurs succeed in finding most of the sondes. When an ozone sonde is sent back, it is cleaned, tested and recalibrated so that it can be used again for a new launch afterwards.